In this video, we're going to review chapter 16, starting with heat, which is thermokinetic energy and measured in joules or calories, and temperature, which is very different from heat. It's an average kinetic energy, which is measured in Kelvin or degrees Celsius. When we look at these two containers of water, the water is boiling. The temperature is the same in both cases, but the pot containing much more water holds much more heat. Next, we have specific heat, which is the amount of heat that's required to change the temperature of 1 gram of a substance by 1 degree Celsius. It has units of joules per gram degree Celsius and is unique to a substance. Like density, it is an intensive property and can be used to identify unknowns. In general, metals have low specific heats because they are rather easy to change their temperature by some degree Celsius. Water, on the other hand, is really resistant to that change and requires more joules per gram degree Celsius, and that's precisely why it has a higher specific heat. Calorimetry, next, is the process that's used to calculate heat change. If we have this setup over here, the Cheeto is releasing heat as it burns, and we can figure out how much heat it releases by figuring out how much energy is absorbed by the water. There's an equation we use, Q equals mc delta T, or Tf minus Ti. The Q stands for the heat, that's in joules. M is the mass, C is the specific heat, and Tf and Ti are the final initial temperatures of whatever is changing its temperature. So we can use Q equals mc delta T to figure out the heat absorbed by the water in this case. Calorimetry is commonly used to determine heat absorbed or released in a reaction, as we see here. It's also used to identify unknown substances by determining their specific heat. Next, we have endo and exothermic processes. Endothermic processes absorb heat. Exothermic processes release heat. In the previous example, the burning food was an exothermic process. The water absorbing energy from it was an endothermic process. Finally, we have the law of conservation of energy, which is that energy can only be transferred and not created or destroyed. And this leads us to the principle of heat transfer. If we have, for example, a hot piece of metal and we throw that into some water, the hot piece of metal will undergo an exothermic process, releasing heat that is absorbed by the water in an endothermic process. It obeys the law of conservation of energy, and therefore we can say that the Q in that is absorbed by the water is equal to the Q out that is lost by the metal. So if we use mc delta T for the water and set that equal to the negative of the mc delta T for the metal, we can figure out any of the variables that we have missing. Most commonly, the specific heat of the metal, which again can be used to identify the metal. Hope this video has been helpful. Feel free to leave any questions or comments in the comment section below, and thanks for watching.